Going to solve quiz 1 of unit 3 of electricity and magnetism that says like this. You have a charge in here that is hanging for a plane. Here we have a plane. This plane is non-conductive, so here we will have this charge. As we can see, the plane is exerting a force through the charge. Here we have our charge, and the charge is equal to 19.7. So here we will have a force, an electrical force in the charge, but also we will have another force that is our mass times our gravity. The mass of the charge is equal to 1.12 milligrams, and we will have here our tension. As we can see, here we can apply Gauss' law and determine that we will have an electric field that will be equal this is exactly the same as the electric field of the plane times the area. This will be our area, and this part here we will have 2 times our electric field because it's non-conductive. So we will have 2 times our electric field, and this will be exactly the same as our enclosed charge on this part over our constant times as we can see here, our enclosed charge will be this part, but this part is equal to our area here times our density. So it's equal to our linear density times our area over our constant. So as we can see, our areas cancel, and we will obtain that our electric field plane will be equal to our density over 2 times our constant. So once we know this, we can consider that this electric plane is a force that is applying here. But this will be not only the electric force, but we have to multiply it by the charge. So this will be equal to the charge times our linear density over 2 times our constant. Once we know this, we can obtain our tension. I'm gonna write here the tension. The tension, as we can see, we have it here, and here we have theta. Theta is our angle, and here is the tension. So theta here will be equal to theta times the cosine of theta, and for the x component will be theta times the sine, because it's the adjacent catet. So as we can see here in this part, we will have the mass times the gravity, and here in this part we will have the charge times the electric field. Charge times the electric field. So the cosine that is this one, will be equal to mass times the gravity, and this one, that is the sign, will be equal to our charge times density 2 times our constant. So here we have two equations that we can solve it by a system of equations. So we can divide them, the tension of the sign of our charge over cosine theta. As we can see, we can cancel the tensions, and sine over cosine is equal to tangent of theta. So all this if we sum it, we will obtain that our linear density will be equal to 2 times the mass times the gravity times our constant, that is here, times our tangent, that was the product of the division of these two, over our charge, that was this one. And we have that the charge was equal to 19.7. The mass was equal to 1.12 milligrams, that is equal to 1.12 times 10 to the minus 6 kilograms, and the tangent of theta. So as we substitute our values, or the total value of our density for the plane, that was the question for our problem, says that our density is equal to 5.12 nanocoulombs over meter square. And this is how you solve it.